Hi, my name is Michael Leworthy, and today we're going to be looking at application performance monitoring using System Center 2012 R2. In this Microsoft Virtual Academy session, we're going to focus on a couple of small things. One of them is going to be the Application Performance Monitoring Overview, or APM Overview. We're going to look at the application delivery lifecycle and how you as an organization can use System Center to actually deliver applications as a service and the life cycle that you will use to approach that. We're going to look at managing and monitoring your applications anywhere, whether they're in a on-premise environment or a hybrid environment. We're going to look at application insights and diagnostics, getting really into the core components of a custom application, whether it's a .NET or Java application, and getting insights around performance monitoring availability for those applications in line with your SLAs, and then look at deeper analysis and reporting to not only provide your IT organizations great analysis, but other interested parties, application owners, CTOs, CIOs, CXOs, the ability to actually provide reporting to. So to start, we're actually going to look at our application management component, and in this case, some of the key approaches and benefits that we use as Microsoft to really focus on getting the most out of managing and operating your applications. And when I talk about that, our approach is to manage and monitor both traditional, public, and private cloud applications. And what do I mean by that? Well, traditional applications are applications that you're going to deploy, on a traditional workload. SQL-based, web-based, maybe off-the-shelf, maybe custom applications. And we want to be able to manage and monitor those through our System Center tools. And we have a number of tools in System Center that allow you to do this, both integrated into the platform and also available through extensions, which we call management packs. And those management packs can either be customized or they can actually be created by a third-party organization as part of their application as well. Associated with this, we also focus on both public and private cloud applications. So a private cloud application is an application that is being deployed in a private cloud, this abstracted capacity in your organization. That actually may be a multi-tiered sort of service-based application. And you can monitor, of course, all aspects of that utilizing our System Center tools, and then extend that monitoring into the public forum as well. So in fact, that you can utilize System Center tools to monitor public-based applications, which applications that are living in Azure or maybe a service provider, and you can monitor, web tiers, application tiers, database tiers, even core services, Azure-like services, storage and database as a service components within our System Center tools. We also want to really deliver performance-driven management of applications with deep application insight and diagnostics. Now, what that really means is that we want to be working, our systems want to work with application owners and IT owners to develop core SLAs. What is our expectation of this application? What is the expectation of the client experience? And once we've got that expectation, that might be performance. We expect this application to return X at within 0.5 or 0.6 of a second, or we expect this document object model to load. We expect something to happen within a variance of time. Now, once I have that information, it's really easy for me to then create the rules associated with that. And once I've got those rules associated with that, the system then will really define these performance-driven management and allow you to allow the system to respond to when those SLAs are broken or neared. And the great thing is that all the data associated with that is then captured. So if I have an SLA that says this website, this web application needs to have all of its models loaded within 1.5 seconds for the client experience, and it takes longer than that, not only will it tell me it takes longer than that, it will have all the information associated of why it took X amount of time to actually load. So I have this deep analysis capability. And then associated with that, we want to provide this proactive monitoring and reporting with application level. Exactly what I was talking about. Once you've built your SLA engines, System Center can be very proactive in monitoring those and then responding to those. So what are some of the key benefits that you're going to get? Well, you've got to be able to deliver applications across both your private and public clouds, allowing you to run applications where it best suits you. We live in a hybrid world now. We swap OpEx for CapEx, based on our usage, based on our needs. We use capacity on the fly in Azure and service providers for web tiers, for development, because, having that capacity to burn peak capacity components is something that the public cloud really excels at. So we want to be able to provide you a platform that allows you to use the system that is best for you at the time and then have a management fabric across all of it, so you don't have to have different management tools for different destinations. Of course, we want to simplify the management of your applications, and of course they're updating, and we'll talk a lot about that by taking advantages of template-driven services. We really want to decrease the mean time to resolution. And this is where a lot of the challenge comes in is, once you've found a problem, how long does it take you to fix that problem? Because generally, it's not the technology or not the bug itself, it's the communication process of getting that problem solved. Especially you have to go through cross departments. We'll talk about what that means in just a moment. And of course, we want to then empower application owners to manage and maintain their own applications. Now, this may sound a bit of a scary statement. I want to give application owners the rights to manage and operate their own applications, but I'm IT, that's something that I want to control. But the concept here is you want to give them freedom and flexibility while continuing to enforce your organizational policies and also processes. So I want to provide them as much self-service capacity as possible, because that takes the load off me as an IT owner. But I also want to ensure that they're constrained within the policies and principles that my IT defines. And System Center is phenomenal at providing this type of solution. So let's talk about a little bit about decreasing the mean time of resolution, because I think overcoming the DevOps disconnect is one of the core components here. Because development, or say engineering in this case, and operational organizations have not been aligned, or not being aligned has really been a detrimental, or provided a detrimental impact on the business from an application delivery perspective. And operations staff view development folks as sitting in their, operations staff view as development folks as sitting in a very isolated environment, cranking out code, and wanting to release these applications without really understanding the IT, constraints. And development sort of see operations as generally a very static, resistance to change infrastructure, where elaborate procedures can take times. And then chances are, in most organizations, this is not as bad as that. And this is an exaggeration, but effectively, sometimes the tension between these two environments can get in the way of deploying a solution. And with the growing popularity of cloud computing, there's an emerging need for the discipline of DevOps that brings together the roles and associated responsibilities. And what that means is this developer doesn't stop just handing their code off to operation counterparts. Instead, that they design their applications so they're optimized to execute in a cloud-style environment. And the developer has enough understanding of the IT operation environment that they can diagnose and potentially resolve application issues that may occur in production. And to make this happen, the developer needs access to rich diagnostic information from their live site operations, and process-based approach to collaborating with their operational counterparts to be able to jointly deliver on these application SLAs. So let's think about this. In the concept here is that you've got IT ops here saying, hey, I just got a call about a failed application, or I've got an issue with this application. And the general response is, from an app dev, do you know what might have caused the issue? And IT ops to say, hey, how would I know you wrote the code? And this may be a common component in your organization. You know, most IT operations are going to ensure the hardware is healthy, the underlying OS or infrastructure is healthy, and then we have no networking issues. At that stage, they're going to go, hey, it's an app fault. It's time for you to work it out. And the app owners are going to go, hey, we don't have the tools associated, the insights available to really understand where the application fault is. So we really want to break down this DevOps disconnect between these two orgs and allow the system, allow the software to be able to answer both these needs, both from an app ops perspective and an app dev perspective as well. So let's look at the application monitoring solution. Now, System Center 2012 provides a complete application monitoring solution. And you know, so if we think about from an infrastructure monitoring point of view. Now, Operations Manager has done infrastructure monitoring for many, many years. And we have an incredibly strong base on which to build. And this is very important because after all, you can't know if an application is performing correctly without understanding if the underlying platform is also performing as expected. But application monitoring builds on this infrastructure monitoring in three ways. First, we have server side. Now this is monitoring at the back end of what has been executed by the application and delivered to the end user. Next, we have client side. Now client side is understanding and capturing the end user experience with the application, including how long it takes to load and execute, network latency, and any client side scripting exceptions. And finally, we have synthetic transactions. And synthetic transactions, these are pre-recorded testing paths through the application. So basically you record the steps you want to complete. And then these are run on a regular schedule to ensure that the application is functional and available. And we extend this with some tools in System Center called GSM, our Global Service Monitor, which enables monitoring of web applications around the globe by running synthetic tests against web applications in Windows Azure. Now, I'm going to come back to that and talk about that a little bit more of what that actually means later on in this presentation, because it's a very exciting space, this sort of outside-in monitoring utilizing Azure. And finally, you're using the same tools to monitor visibility across infrastructure and applications. And this is really important for an IT ops point of view. I use the same tool set, both from a server-side monitoring, client-side monitoring, and synthetic monitoring associated with this environment. So let's jump into the application delivery lifecycle and talk a little bit about why do we need to start thinking about service-driven applications instead of the traditional way that you may build an application today. All right, well, if I think about the application delivery lifecycle, the concept here is I want to have scalable, standardized, and predictable applications. Now, in a cloud context, applications are what you use and services are how they're delivered. So in order to gain maximum benefit from the capabilities that become available in your private cloud, you need to be able to deliver your applications as services in a scalable, standardized, and predictable manner. Now, we do this through a couple of key constructs. Now, first is abstraction. So by encapsulating the application in, say, what we call a server app V bubble, we can maintain a consistent form of the application, dynamically configure it at deployment, and actually remove the tight coupling of an application with the OS. Next, we think about consistency. Now, consistency is using a concept called service templates. And service templates provide the mechanism for deploying applications within a standardized specification. And this includes hardware requirements, OS support, and server roles required, and then also how the application can scale. Next, we have insight. Now, insight is where Operations Manager application performance monitoring builds on the infrastructure monitoring which we talked about before, bringing deep insight into application performance based on their end user experiences, along with rich reporting and also trending information. And finally, we have control. A key capability delivered by the cloud, a key capability delivered by cloud context is the ability to delegate access to the resource and apply quotas to ensure the hardware resources are shared in a manner that allows applications to be delivered within the SLAs defined for them. App Control is a great tool that can be shared between both app owners and IT owners to deploy these service-driven applications. So let's go into think a little bit more about the application delivery lifecycle and how all these things come together. So when you look at the application delivery capabilities we deliver in System Center, we're enabling the complete application delivery lifecycle. So first we start with the application specification, where we define what the application is, what the requirements are, and then the resources that make up the service that is delivered. Then we capture the application as it needs to be delivered in the service template, where we define scalabilities, tiers, and things such as SQL data access connections. As we deploy the service, we can dynamically customize the application with instance-specific information, and then the service is actually deployed. And we have to expect that the application instance is going to require updating over time. So we provide the mechanism to update individual resources within the template and also publish a new version of that service template. And this new version can be delegated to the owner of the application to apply at a time of their choosing. So this really provides a great way to standardize our application provisioning. So let's talk a little bit about that. Now let's take a closer look at the breakdown of how a service template comes together to deliver that application. So we start with the structure of a template and how we define the tiers that exist for the application. And each tier has its own scale-out policy defining if this tier of the application can be scaled, and if so, what the scale settings are, the minimums, maximums, and so on. And there's also 3 profiles that can be configured for each tier. The hardware profile, which defines the resources that the tier requires, such as CPU, RAM, etc. The OS profile, which includes things like what Active Directory to join, any server roles to install, and what OS template to use. And then finally, the application profile, which provides the application resources and their associated configurations. Now the great thing here within these profiles is not only do we have the web tier components, application components, we also then have the SQL profile. And the SQL profile includes details around the SQL DAC packs, which are the data tier application packages, databases, and also SQL configurations to be deployed. And then the template is then saved, validated, and stored in the service template library so it can be delegated for deployment operations. So let's just go back and look at this again. The idea here of our standardized application provisioning is to be able to create different tiers for the different components of our application: web tier, application tier, and data tier, and then isolate these utilizing the 3 core settings: the hardware profile, which is going to configure all the expectation of that virtual machine, memory, CPU, the way the disks are associated with it, etc. The OS settings, so what components within Windows Server need to be deployed, what roles, features, and functions. And then, of course, an application profile. So in our web tier, we're going to have an MS Deploy package and configuration. In our application tier, we're going to either use a application configuration or AppV. And then in my data tier, that app tier is going to be my SQL profile. The great thing here is you can see that all these could be, of course, one profile. And when they're one profile, we call them a VM template. By separating these out, allows me to modify, deploy, and scale each of these tiers individually. So if I have capacity issues in a web tier, I can scale that web front instance without affecting the application tier or the data tier. It's very, very exciting technology. So let's look at standardizing with hardware profiles And let's take a little bit of a deeper look in those. And there's three sets of information that could be configured in our hardware profiles. First, compatibility. So you can simply define which virtual machine hosts offer the required capabilities. And you can also define your own profiles. Next, we have definition. Definitions define the virtual hardware's requirements such as number of processors, memory, bus configuration, whether you're using IDE, SCSI, networking, and so on. And finally, we have execution. And execution, these specify characteristics of the runtime environment. Should the VM be highly available, the device boot up order, the CPU priority, things like NUMA, memory weighting, which is the priority for allocating memory when memory usage of the server is high. These allow us to all standardize the components of our hardware profiles. Next, let's look at going a little bit deeper at our application profiles. There's also three sets of information that can be configured here. First, we have compatibility. So here we can simply define which OS versions and editions are completely supported by this application profile. Next, we have definition. Definition allows us to configure things like time zones, product keys, and the local admin passwords. And finally, we have execution. And execution, so some application tasks that may not easily be captured, and these require things like a pre or post script. These can be configurations, agents, or also other items that are associated with our execution tier. Finally, let's look at our SQL profiles for automating the SQL deployment. And deploying SQL within a service template as a key workload is something we actually make really simple. So starting with the deployment of SQL Server within a template, what we're looking here is for consistent SQL configurations with the ability to define named instances and products keys to use. Next, we can set the configuration details for the SQL installation from the media source locations to the security mode and also the network connectivity configurations. You can even include a SQL configuration file. For the applications, we can also configure the connections, and these include DAC connections, the instance definition, authentication modes, and also what behaviors will be followed when we upgrade or migrate the application. And finally, we can capture the service account information, which accounts are used for each SQL Server services. So you see we have a lot of power to completely abstract the deployment of an application, whether it's a single tier application or a service tier application where I have multiple tiers within this services library. I can completely abstract that from any physical deployment, allowing a consistent, repeatable, and scalable approach in deploying my service applications. So next I want to talk about deploying applications across clouds because this is a very interesting scenario. What we've talked about is creating a service-driven application template to deploy my application as a service abstracted from the physical hardware. This also allows me to deploy this application across cloud or in a multiple cloud environment. So let me give you an example of what that may look like. But the great thing here is it's fully flexible and dynamic. So I have a private cloud infrastructure which could be running on-premise or could be running in a hosted service provider, but effectively it's running as a private cloud. And then I have a public cloud infrastructure. This may be Azure or a service provider providing a public cloud type service. Maybe it's database as a service or websites as a service associated with that. In this case, I could actually run my web tier and my application tier on-premise. They could actually be running in my private cloud, and I could run my data tier in my SQL database in Azure. So I could actually run my database as a service in Azure serving these environments. I can actually do this the other way around as well. I can have my database running on-premise and my web tier running in Azure or a service provider. That's actually a very popular configuration with many of our organizations where they actually have data tiers running on-premise and actually web tiers and even application tiers running in Azure. Why would I do this? Well, public cloud gives me a couple of really great features with the ability to scale on need. So for example, let me think. I'm a seasonal organization that sells online goods. Now, I'm going to have a couple of really big spikes through the year. I'm going to have a Black Friday spike. I'm going to have a Christmas spike. I might have a sale in July. I might have a Labor Day sale. I've got these big spikes. And during those spikes, I actually might experience 100 times increase in traffic. Let's just say that. Now, generally, if I'm an on-premise organization, I'm going to have to build infrastructure to support my largest spike. So generally, I might have to actually build 5 to 10 times more infrastructure to support these 4 or 5 spikes that I'm getting through the year. But 95% of the other time, I have a sustained sort of environment. Public cloud allows me to have that instant scaling capacity, and I pay for only what I need at that time. And our hybrid cloud approach allows you to develop once and deploy anywhere, whether it's in Azure and a service provider or on-premise. So I can say, you know what, my web tier and my application tier, which are the ones that are serving my online application, I can host these in Azure or in a service provider providing these types of services. And then when I have that 100 times hit coming up to Black Friday, these systems will completely just scale out seamlessly and load balance seamlessly based on my service template-driven approach. And I can actually ensure that I have 100% uptime and reliability and only pay for what I need. And as usage drops off after those times, then those systems will automatically scale down. So it's a very exciting environment when we think about a hybrid environment across all those areas and be able to use what's best for me at the time, whether that's on-premise or whether that's Azure, whether it's service provider or whether it's a hybrid approach. The great thing here from a service template-driven approach is I build once and deploy anywhere. Next, let's actually think about our hybrid cloud deployments and think about our managing and monitoring these applications anywhere and how we can do this. So first I'm going to start thinking about application operating models in a private cloud. So what are the different application operating models in a private cloud? And we think about this in 3 buckets. First, there's traditional applications, and this is where many organizations are today. And this is the standard application that's running on an operating system. And we do provide this support for these applications, of course. And of course, support for workloads, older applications, and existing end-market applications. And this is a standard application that might have been deployed using an image side package, and it's running on an operating system that it could either be physical or virtual. The next model we look at is consistency, and this is where we deliver the same standard application, but we do that using a service template. What this brings is that we're able to deliver a consistent application in the term of structure, and exactly how we've sort of talked through service templates components before. The last one we'll look at, of course, is an abstracted model. I mentioned this briefly in our service model. This is when we're using Server App V, when the full potential is private cloud is fairly much unleashed. Scalability is a lot easier, patch management becomes a lot easier, and this way we can recompose and so forth becomes a lot easier. And there's no right or wrong place for customers to be sitting in this model. And this is purely a way of giving our customers a different way to sit and deliver application in a private cloud. And there's certainly benefits from when you move from traditional to consistent to abstracted. But the very key point here is this is not a maturity model. It's simply different places to be sitting. And our focus here is to be able to manage each of these areas wherever your application is sitting, whether traditional, consistent, or abstracted. Now, if we think about managing these applications across multiple clouds, this is a conversation that comes up a lot where we have customers that have some key on-premise applications, and maybe they're looking at Windows Azure applications and they need to understand, how do I actually do this? And this is how we do it. We have 2 constructs here. We have a private cloud on the left-hand side, which is a virtual machine manager cloud. And then we have multiple hypervisors we support: Hyper-V, VMware, Zen. And then we have a service template model that sits on top of that to deliver our applications. And on the right-hand side, we have Windows Azure, or maybe even a service provider, which is a package and configuration model. And we want to be able to do, what we want to be able to do is deploy, monitor, and manage your applications regardless of where they're running. And the way we do this is with App Controller. And App Controller enables us to manage both, on the left-hand side, a virtual machine manager service, and then on the right-hand side, either Windows Azure application running with from a single console, or a application running in a service provider. And we can see the information on what's running, we can see how many instances are running, and so forth. And we can even go through and perform actions against these services, as well as deploying new applications on both the private cloud and public cloud infrastructure. Very, very powerful tool in managing these applications across multiple clouds and having that single consistent view to deploy, manage, and monitor them. However, let's talk a little bit more about a multiple cloud deployment and things that we can do to support that. You know, I want to take a little bit of a sidestep here and really talk about something around self-service capability, because effectively what we're talking here is the ability to create service-related applications and then have application owners or other consumers have a self-service experience in deploying them, maybe managing them, maybe even maintaining them, but also within the processes and requirements of my IT organization. And if we think about public cloud infrastructure, they do this really, really well. So the concept here is they have a very consistent, familiar self-service interface that every subscriber uses to provision and manage services, such as websites, virtual machines, etc. And they do this via a great self-service experience or a REST API and a management API on top of that. And effectively underneath, it's very, very similar to what we're providing with an on-premise private cloud. It's an abstracted service, whether it's an application, whether it's an IaaS, and then it's a self-service experience to be able to deploy and manage that. And I get a lot of questions about, I think this whole concept of public cloud infrastructure is great, and it really provides a great self-service experience for me to be able to expose this new service-related application delivery model that I'm developing internally. Couldn't we have something like the Azure technology and actually you could just build that up on premise? And in fact, we now have that component with this new technology, which we call the Windows Azure Pack. So let's think about this. We can provide this core OS component, which is enabling parity of our application owner experiences, irrespective of where the underlying infrastructure may reside, whether it's on-premise, in a hosted environment, or on Windows Azure. And to do this, we need to ensure that tenant end users have a uniform self-service and management experience to consume the infrastructure needed by the application services for both Windows Azure and also Windows Server environments. Now, enterprises and service providers are already running a sophisticated operating system, virtualization, and management platform in Windows Server and with System Center in their own compute, storage, and network infrastructure housed in their own data centers. Now, what the Windows Azure Pack does is it takes Windows Azure technology developed for Microsoft data centers, and then it repurposes it to provide the same capabilities running on System Center and Windows Server in your own infrastructure. So this component allows this consistency to become a reality between the three core environments: your own enterprise, Windows Azure, and also service providers. And we've found Windows Azure to be a great environment for developing and testing highly distributed cloud services. And now we're bringing all that technology to the hosting service providers and enterprises as part of the technology found in Windows Server and System Center. And as you can see, we have consistency in the portal, in the API, and also select services across all these three areas. So why is this useful? Well, it enables you to create a very consistent way that you're going to develop your applications, a consistent way you're going to provide self-service experiences, which may be the same in all of these three areas, allowing you to be the cloud broker. It allows you to create a very consistent billing usage based pricing, whether you're doing show back, look back, or charge back. It allows you to create a very consistent automation component. It also allows you to do integration and customization. Basically, with the Windows Azure Pack, you as an enterprise or a service provider can have Azure technology running in your data center today. And I really want to stress here, it's important to note that these services are deployed on your infrastructure, meaning you don't need to make new infrastructure investments to make this vision a reality. You can basically leverage what you already own. And the core concept here is it provides, built on the foundation of Windows Server and System Center, a number of core great things. Windows Azure consistency in both user experience and services ensures IT administrators can reuse their skills and automation across all Cloud OS destinations, and also move workloads to use the common set of services across the Cloud OS. Allows me to move workloads from Azure to on-premise to service provider based on my usage at the time without recompiling, redeveloping, rejigging those. Website Service provides a consistent, scalable, and reliable application platform for running websites and web applications, again, across all these three environments. The multi-tenant infrastructure of the Windows Azure Pack enables efficient shared usage of commodity compute, storage, and networking resources. So load balancing for web applications and VM roles enables users to directly control their scale-out resources required by the application workload, making the best of your investments in hardware and investments in Virtual Machine Manager. Out of the box, Windows Azure Pack provides a ready-built Windows PaaS, or Platform as a Service, Web PaaS, Platform as a Service, and IaaS solution for enterprises to offer internal services or service providers to build customer offerings. And also using the advanced features in Windows Server and System Center, you can build the solution on inexpensive industry-standard hardware. The Windows Azure Pack also provides a wide range of customization and integration possibilities. The management portal could be branded or completely replaced using the Service Management API, and billing can be completely integrated through the supplied API as well. It's a very phenomenal feature when you think about how to create a consistent way to deploy applications across multiple clouds, and a consistent way for your users to access those applications, again, across multiple clouds. The key here is if you want to create a very consistent self-service experience, the Windows Azure Pack can do that. You can completely partner this with your customized System Center experiences as well. So you can have customized System Center-based experiences utilizing your service template infrastructure, partnering with the Windows Azure Pack as well for those scenarios such as dev test experiences where you want to create a consistent framework self-service user experience across multiple clouds. Now, one of the key things that this is based on is this technology which we call SPF, or the Service Provider Foundation. Now, I really just wanted to introduce this a little bit. We won't talk too much about it, and you get plenty of information on TechNet about the SPF. The SPF Foundation is provided with System Center 2012 Orchestrator as a component, and we introduced it in System Center 2012 SP1. And effectively, SPF exposes an extensible OData API that allows our web service to interact with the components of System Center. I mean, this enables enterprises and service providers, organizations, really to design and implement multi-tenant self-service portals that can integrate IaaS capabilities available through System Center 2012 SP1. This is the key behind many of your IaaS solutions, whether you're building customized IaaS solutions utilizing System Center, or utilizing Windows Azure Pack solutions, of course, again, utilizing your infrastructure investments in Windows Server and System Center. All right, so we've talked a lot about application development in the sense of creating the services that we're going to deploy an application. We've talked about the platform that application may use. We introduced the Windows Azure Pack as a capable application associated as your, part of your arsenal in supporting self-service solutions across multiple clouds. Now I want to talk about application insights and diagnostics. Once we have these applications deployed, how are we going to ensure that they're healthy? So we've focused on deployment of our application as a service, abstracting it from the traditional physical model, maybe creating a single tier, maybe creating a multi-tier template. The idea behind that is that we now have a repeatable, scalable, and predictable way that we can deploy our application wherever, whether it's public cloud, hosted cloud, or on-premise. We now have the same set of tools to be successful on that. So now we have to think about insights and diagnostics. How do we ensure the performance, availability, and health of this application? So we're going to look at this a little bit deeper with the idea of predictable applications for your SLAs. And what do I mean by that? Well, as one of the brighter days of any IT ops person is ensuring they're all green, that when you see the reports, when you see the monitor, everything is green, that we're all running really well. So we're going to look at how we manifest our goal of getting to green. Now, many of you may have seen application health dashboards with System Center before. And we've actually made it really easy to create and customize dashboards that track application health. And you can also share these applications dashboards with counterparts in your organization, all the way from peers up to senior management, and very easily define certain characteristics and customize certain characteristics that they may want to see. Now, we've invested really heavily in the application performance management capabilities in System Center throughout the years, and especially in R2. And what we're going to talk now through is a small view of an end-to-end scenario which uses deep application insight to enable you to deliver predictable application SLAs to your business stakeholders. Now, the great thing about System Center is any recently deployed application service is discovered by System Center Ops Manager through the Virtual Machine Manager connector. And you can see a comprehensive view of application dependencies and also relationships down to the infrastructure resources. The great thing here is also, from a diagnostics point of view, you can easily pinpoint where the problem may lie as part of that distributed model. Because you think if you have a service template model, you may have multiple tiers. You want to ensure that you know the offending issue very easily in your analysis. Next, what we want to really do is look at some of the threshold values or parameters, and you can actually configure the threshold parameters of your application service to enable comprehensive monitoring through a number of different perspectives. So what I'm talking about here is that through your SLAs you can actually set up threshold parameters which will be measured against within System Center. So you can look at things such as application component monitoring. So this is about deep dive monitoring on the actual code executed by the application. You can look at synthetic monitoring. Now, synthetic monitoring is using pre-recorded testing paths through the application that highlight availability, response times, and also unexpected responses. And finally, you can also use end-user monitoring. Now, what end-user monitoring is actually monitoring for end-user experiences related to page load times and also server and network latencies. Now, you can set up all of these three things as part of your SLAs and thresholds associated with those, and then the system will continually measure against those thresholds, reporting that information out to you. So in this case, you can see here through this visual tool that our application needs a little bit of fine-tuning. And now what we can do is identify the symptoms of any issue using some of the granular diagnostic information which is presented by Operations Manager. Now with Operations Manager, we can use this thing called AppOps. Now AppOps can isolate the root cause of the performance issue down to the offending line of code pretty efficiently, even when you've not written the application yourself. And this capability was originally offered by a technology called Avocode, which we acquired back in October 2010, and has since now been integrated natively into Operations Manager. Now, System Center 2012 doesn't stop there, and we allow, from our once we've isolated our root cause, we can now send all those details about the failing code section to our application development counterpart pretty easily. In fact, we have a connector between Ops Manager and Visual Studio that creates a work item in the developer queue so it can be triaged as soon as possible. Additionally, System Center 2012 R2 also enables IntelliTrace telemetry between Visual Studio and Operations Manager, therefore making it more easier for developers to actually debug the issues. So it's a very, very exciting technology in enabling a whole vision for us to how to get to green through application dependency insights, monitoring client and server components of the application, easily isolating the root cause, and then be able to triage and remediate those easily. And we call this the 360-degree view of application health. And with the release of System Center 2012 R2, customers now have an extensive and enhanced 360-degree view of their entire application. So let's actually walk through a couple of these. So with System Center, you can now automatically perform availability monitoring through both Global Services Monitor and also internal synthetic transactions. Now I'm going to talk a little bit about what this is, but let's just spend a minute on this. Now, in previous versions of System Center, you could do website health tracking, which we called internal synthetic transactions. And what this enabled you to do was to record a typical path through your web application, a synthetic transaction path, and then be able to replay that path to test the response of that application. And that's great. We call that inside-out monitoring, where your systems are actually monitoring the health of your application. And that, as I said, that works a phenomenal solution, and you can actually build up test pads where you need to. We then extended that through Global Services Manager, which I'll talk a little bit about at the end of this presentation, which takes that whole idea of internal synthetic transaction monitoring and makes it available in Azure, so outside-in monitoring. So instead of you running the tests, Azure's running the tests for you. And I'll talk a little bit about what that means and some of the benefits you can get that really soon. You can also do reliability monitoring through our .NET application performance monitoring and also our Java application performance monitoring, which was released in our R2 timeframe as well, including GSM associated with that. You can also do performance monitoring through our APM tools, both for .NET and Java, GSM, and also client-sided monitoring. And you can do diagnostic monitoring, again, through all those areas. All this information can be automatically captured and then through seamless integration into both operations and development tools, it means faster time to issue resolution. So let's actually have a look at some of these in a little bit more detail, starting to responding to application performance issues. So let's actually have a look at what this graphic is showing here. From a response point of view, you can see that we have a threshold of 500 milliseconds. However, we've gone well over that. So if we drill in this a little more, you can see that what we expected the end user experience to be was 500 milliseconds. The actual end user experience ended up being a little more around 1200. So we've definitely got a problem here. We've got an end user experience here. Effectively, our configuration of our SLA was 500 milliseconds within our tool. But the system has now measured an end user experience impact of around 1200 seconds and has now come back to us and said this is a break of the SLA. And not only that, it has captured all that core information associated about why this problem is happening. Now, if we start to think about System Center all up, we actually start to bring about all the other components that can come together around all this information, not just the break of the SLA and the capture of this sort of end user experience configuration issues. It's all the information that System Center can actually use to respond to an application performance issue. So if we configured Service Manager our environment, the Operations Manager to Service Manager connector means that whenever this alert is raised in Operations Manager, then it will also go along the Service Manager and raise an incident. Then this can go through different escalation paths, the developers, network, and infrastructure guys. And we can capture all that knowledge, and perhaps we have some automation remediation going on. And when you resolve this issue on the Service Manager side, it will also close the alert on the Operations Manager side. So think about this. This is really exciting here. The concept here is that we've broken an SLA of 500 milliseconds. Service Manager as our ITSM tool is doing automated remediation, either automatically opening a bug to our developers, capturing network information and sending that to our network team, capturing infrastructure information and sending that to our infrastructure team. Maybe there's automated remediation based on that. The big thing here is all that knowledge is then captured into our Service Manager database for archival purposes and organizational insight purposes. And then once this is resolved, the Service Manager will control the resolution of this issue and closing this alert. So, it's a key component of System Center 2012 and why all the different components can come together and light up this very rich scenario where you've got Service Manager, Orchestrator, and Operations Manager all coming together to do some very impactful application performance monitoring. Now, I might have mentioned before about Java support. We talked about, supporting .NET applications, and I mentioned some Java applications as well. And we've got some great Java support for application performance monitoring within System Center. And some things that are new in R2. Now, previously we used to be able to support the Java Enterprise Server and actually do performance monitoring on the enterprise server itself and the health of the server supporting the application. But now we can actually get into the Java application as well. So you can see that we can do performance and exception alerts within the application advisor for Operations Manager, and actually, really focus on method and resource timing, stack traces, Java-specific counters, and also provide a great componentry of the APM supports for Java. So very similar to what we do with .NET application performance monitoring, where we can use that app diagnostics tool, we can now do the same for Java application monitoring as well. So it's a great tool for heterogeneous support. We also still support Ops Manager level alerting for Java application server, and you can see that we support a bunch of those things there. Now, I mentioned that I was going to talk about Global Service Monitor because I think this is one of the most exciting technologies that was introduced in System Center 2012 SP1 and we've continued to invest into the R2 timeframe. And this is the idea of outside in monitoring. And it's a really great example of our comprehensive monitoring and deep application insight that we've now enhanced in the 2012 family. The idea here is this, creating a rich end-to-end scenario from the creation of web tests to external outside-in monitoring, integrating, on-premise monitoring and rich developer diagnostics in the case of any detected exceptions. So let's actually have a look at a global service monitor here. So on premises, you're going to have developers working in Visual Studio 2012. And Visual Studio 2012 enables developers to create web tests to validate that the applications are functioning correctly as part of their dev test environment. The great thing here is a subset of these tests you can import into Operations Manager, which can be actually used to configure the Global Service Monitor tool itself. And the Global Service Monitor is a service hosted in Windows Azure points of presence around the world that enables organizations to assess the real-world performance and availability of their applications. So our concept here is Operations Manager instructs our Global Service Monitor which application endpoints to invoke with which web tests along with a schedule. And then once configured, Global Service Monitor calls the production web application according to the schedule and then returns the results to the on-premise Operations Manager for display alongside other monitoring data on the application gathering within the organization's private network. And this capability ensures the broadest set of data to assess the health of an application and when intervention is actually necessary. When Global Service Monitor returns either an exception or response times that trigger an alert in Operations Manager, Operations Manager can schedule a work item to be added to the developer's queue to be addressed by that developer. I mean, this level of integration helps to accelerate issues to resolution and also achieve SLAs. So let's just recap what we just saw here. I developed my application utilizing Microsoft Visual Studio, and as part of that I may be using a customized web test to support that, to test that application. I can take that exact same web test through System Center Operations Manager and deploy that into my Global Service Monitor, which is a point of presence, multiple points of presence around the world within Windows Azure. And using that web test and a schedule of my choosing every 5 minutes, every 10 minutes, every half an hour, every day, I can test that application, that production application, and then actually have rich results returned back into my Operations Manager. So this is great. And you can say, oh, this is great, I can see that. But the concept here is you're testing the application from where your end users are. So think about this. I have an application that's hosted in New York. And it's a global application, and I have customers in Sydney, in London, in Sao Paulo, in Singapore. For me to test the experience of that application in Singapore, effectively I have to have a test service in Singapore. I can't test the end user experience from Singapore in my New York data center. I actually have to have something in Singapore. So this could be quite an expense for me to be able to do this on a worldwide basis. I can use GSM to test that end user experience in Singapore. There's an Azure point of presence in Singapore. There's one in London. There's one in Sao Paulo. There's one in Sydney. I can use these points of presence to test that performance availability of that application at that time in their location and then return that information back to me. So our concept here is that I can actually set up different SLAs based on where this information is coming from and then actually respond to those SLAs. So you can see here that I can have a point of presence response back from these multiple points of presence, and at the moment we support 16 points of presence with Global Service Monitor. I can have a look at their transaction response time based on my SLAs, based on the information that I'm feeding the system, based on the performance and availability characteristics of this application that I require, and then I can determine alerts a function on that as well, fully integrated back into my Operations Manager environment. So just a recap of what it offers here, it offers the availability component, the ability to understand the availability of external facing services. It enables us to accurately measure and adhere to my SLAs. It provides full integration as part of my Operations Manager environment, and it's efficient. It's managed by Microsoft and extends your SCCM infrastructure completely into the cloud. So let's summarize with some of these DevOps APM scenarios that we've just talked about around our application performance monitoring, and really where we can use APM to really sustain the DevOps operations. So the concept here is that there are a number of fundamental tools that System Center provides, from APM discovery, monitoring and availability, and then reporting, that helps both our operations organization and our developer organization. But there's also a number of features that then build on top of that. So for example, our Global Service Monitor can actually use web tests that have been developed as part of their APM lifecycle into Operations Manager, allowing sharing of those artifacts. So Operations Manager, as we mentioned, is fully integrated with Team Foundation Server that allows you to create work items or bugs straight into TFS from Ops Manager, either manually or fully automated. It works together with any development process model that TFS may have. It provides that two-way synchronization, so as information is added in the bug in TFS, that information is historically archived in Ops Manager as well. It allows easy configuration with the Ops Manager authoring wizard. Our APM monitoring events can actually be opened as IntelliTrace from Visual Studio. We completely have a deep dive into problem root cause analysis with the IntelliTrace Profiling Management Pack, and this is completely extensible through the System Center Orchestrator. So not only do we have a core set of APM tools to be able to capture those diagnostics, you can see here we have these key DevOps APM scenarios which integrate these two worlds completely. Now what I want to do now is show you a demo of these fundamentals working together and show you deep APM analysis, GSM integration, and mean time to resolution.
Fourth Coffee recently deployed a new website, and to ensure peak performance are using System Center 2012 R2 application performance monitoring to monitor health performance and availability. Now, new in System Center 2012 and enhanced in System Center 2012 R2 is Global Services Monitor. Now, System Center Global Service Monitor is a cloud-based service that addresses this problem by extending the application monitoring capabilities in your System Center 2012 beyond your organization's own network boundary. Global Service Monitor uses Windows Azure points of presence to help give you a true reflection of an end user's experience of a web application. Now, we can clearly see that we're having issues in a number of places where our transaction time is over the expected SLA. Now let's use the power of System Center APM to understand what that error may be. The Alert view in Operations Manager can show me alerts from hardware, workloads, and many other places in my data center. This view is showing errors that are related to my applications monitoring. We can definitely see we have something wrong here. Now let's choose one of them to understand more. When selected, I get a similar experience to selecting any type of Operations Manager alert. I have access to alert information, product knowledge, company knowledge, and even history. Now, something new you might not have seen before in an alert is a link to a tool which is called the App Diagnostics tool. Now, this tool is a web-based form which collates all application monitoring information for clear diagnostics. I can see all the properties for the application fault, parameters, even the code that was being used at the time. It can also provide different views to understand the exact cause of the issue. Here I can see a graphical representation of the error, and it's easy to see that this load time was in excess of the threshold. I'm guessing you're asking, why is this a web tool? Well, so developers can use it too. Yes, they get a link to this tool and can access all the information Operation Manager collects through this easy UI, performance, chaining, and even code tracking. As per our previous view, we have a code error, and I need to pass this now on to my development team. To make this also seamless, Operation Manager now integrates fully with Visual Studio Team Foundation Server through a connector. I can simply choose to assign this to engineering, and click OK. And now all the information we have captured will be synced to Team Foundation server and a bug created for the developer team to fix the problem. With 360-degree application performance monitoring, diagnosis, and DevOps, Operation Manager offers a deep application and transaction monitoring insight for .NET and Java applications and helps you efficiently isolate the root cause of an application performance issue down to the offending line of code. Outside-in monitoring with Global Services Monitor and Operations Manager provides you with real-time visibility into your application performance as experienced by your end user, and Operations Manager and GSM integrate with Microsoft Visual Studio to facilitate DevOps collaboration, thereby helping you remediate application issues faster.
Now we're going to finalize looking at our deeper analysis and reporting. In this concept, we're going to look at how to use the System Center reporting engine to quickly create those key visual reports that you'll need yourself to monitor the systems, but also reports that you can actually deploy out to other people in the organization. So out of the box, Ops Manager comes with a bunch of pre-configured dashboards with many KPIs for instant information, such as network dashboards, the Operations Manager health dashboard, and so on and so on. And they serve not to only provide a lot of rich information out of the box, but also showcase how to bring many of these things together. You can also use a wizard-driven custom dashboard development, which is effectively right-clicking and choosing the information required. You basically select your layout, select the KPIs you want to cover, specify the scope, and then tune that information that you want, or tune that visualization that you want. And then basically you can publish them out. And you can publish them out to many different forms, through SharePoint, through Web Console, and also into Ops Manager as well. And you can then define delegative control associated with this. And to give you an example of one of these reports, you can see here here's a server performance report for an application within Ops Manager as well. So you can get information about the application physical component associated with this within Ops Manager quickly and easily within that single view. Now in System Center 2012 SP1 and also R2, we then introduced a new report called the 360.NET Application Monitoring Report. Now what this does is it takes all those aspects of GSM, .NET Application Performance Monitoring, and my Web Application Availability Monitoring, and then summarizes these up in a key reporting value, including your SLA. So you can see here I've got SLAs for application health down the bottom, all the availability, performance, reliability, response times in the middle, and then any of the alerts up the top. Then you can integrate this with the Java new APM monitoring as well. Again, it gives you another out-of-the-box report view associated with this. So in essence, out of the box, there is a number of rich APM reports that you can utilize today. And then you have all the plethora of information to actually build utilizing a wizard-driven component, any of your reports, and then publish them out either through your Ops Manager console for people to be using that, through a web console for delegated administrative access, all through SharePoint parts as well. Now the good thing here is that it's a consistent view across all of those, whether your users are using Ops Manager or using a web console, they have consistency in that report type viewing. Now what about monitoring Windows Azure applications? I mean, we've looked at how we do this with on-premise applications. Now let's quickly look how we do it with Windows Azure applications. So we're going to start with an on-premise Ops Manager over here, which is doing all the performance, data, event logs, and so forth. And what happens is you do this certificate connection out to Windows Azure applications, as we did with App Controller. And what this does is it reads all the application worker roles and structures and then writes all that information out to the table storage inside Windows Azure, which is then read by the operations data and grooming. So what we have here is Ops Manager on the left-hand side, reading all this, reading all that structure in a dynamic fashion, using the management pack of the Windows Azure application, and then getting all the performance data, event logs, and so forth back through that table storage mechanism. What this means is we get the Operations Manager console diagram view can now cover both the on-premise information as well as the Windows Azure application roles that are out there and what their current performance status is. All right, so let's recap of what we looked at today. We looked at our APM overview information. We looked at the application delivery lifecycle and how System Center integrates into that. We looked at managing and monitoring applications anywhere. So once we've delivered our service-based application, how to manage and monitor that. We looked at application insights and diagnostics, utilizing our APM tools. And then we looked at how we could create some reporting components around an analysis. So hopefully you enjoyed this presentation. If you want to look at some next steps, you can download some evaluation software on our TechNet Eval Center. Also ensure that you look at the Microsoft Virtual Academy other offerings that are completely available as well to boost your technical skills. Now, getting certified is key, and there's many certifications both in Windows Server and System Center to really help you get hired, get recognized, and really get ahead. And then you can evaluate online through our TechNet Microsoft Virtual Labs. And we have a number of virtual labs, including some phenomenal APM virtual labs up there as well. So hopefully you've you learned more about our application performance monitoring components that we have available in System Center 2012 R2 today, how to deliver functional, repeatable, and scalable self-service environments, and how to then take your workloads, take your applications, and create great service models associated with those. Thank you.